Hello everyone, this is Sahana from Shri College of Engineering, and today I am going to explain the topic on computer network, that is error detection method. Firstly, in the contents introduction, types of errors, parity check, checksum and cyclic redundancy check. Introduction. Data can be corrupted during the transmission for reliable communication, so the errors must be detected and corrected. The error detection and the correction are implemented either at the data link layer or the transport layer of the OSI model. The error detecting code is to include only enough redundancy to allow the receiver to deduce that an error has been occurred, or which error and have it request a retransmission. The error detecting uses the concept of redundancy, which means adding extra bit for detecting the errors at the destination. Next is the types of errors. First one, the simple parity check. Here the data sent from the sender will undergoes a parity check. One is added as a parity bit to the data block if the data block has an odd number of ones. Same as the 0 is added as a parity bit to the data block if the data block has an even number of the ones. This procedure is used for making the number of ones even. Thus, this is commonly known as an even parity checking. In this example, we can see the simple parity checking method. The sender will send the code as 100011. Here we can see the number of ones is odd. Therefore, it's sent to the compute parity bit. It will add the 1 to the data block and send to the transmission media. The transmission media helps to send the same data to the receiver, and here it will check the even number of the data block and thus accept the data. In this example, we can see the 2-bit error. Therefore, there is a disadvantage of simple parity checking method that it only the single bit error is detected by this method, and thus it fails in multi-bit error detection, and it cannot detect an error in case of an error in 2 bits or more bits. The second method of error detection is checksum. The checksum is an error detection which detects the error by dividing the data into the segments of equal size and then uses as a ones complement to find the sum of the segments, and then the sum is transmitted with the data to the receiver, and same process is done by the receiver at the receiver side. Thus, all zeros in the sum indicates the correctness of the data. In the first step, that all the data is divided into segments, that is K, in a checksum error detection scheme, and each segment has a m bits. For finding out the sum at the sender's side, all the segments are added through ones complement in arithmetic. And for determining the checksum, we should complement this sum. Along with the data segments, the checksum segments are also being transferred. All the segments that are received on receiver side are added through the ones complement in arithmetic to determine the sum, and then complement of the sum. Thus, the received data is accepted only on the condition that the receiver the result is found to be 0, and if the result is not 0, then it will be discarded. Here we can see the example for the checksum method, that is the original data that consists of 4 data blocks, and that is sent from sender to the receiver. In the sender side, first we consider the data block 1 and the data block 2 and do the ones complement with it, and the result has been added with the third data block and do the ones complement with it, and that final result has been added to the data block 4 and thus find the ones complement and thus considered as the sum, and the checksum is obtained by doing the complement of the sum. At the receiver side also similarly we consider same data block 1 and data block 2, do the ones complement with it, and that result has been added with the third data block and find the ones complement, and that result has been do the ones complement with the data block 4 and final result is being considered, and the final result has been taken with the checksum from the sender side and do the complement, and thus we get the sum as all ones, and this complement we found as all zeros, and thus the conclusion is accepted the data. Here the disadvantages is in this checksum error is not detected if one subunit of the data has one or more corrupted bits and corresponding bits of the opposite value are also corrupted in other subunit. Thus, the error is not detected in this situation because in this case the sum of the columns is not affected by the corrupted bits. The third method is cyclic redundancy check. The checksum scheme uses the addition method but CRC that uses binary division. A bit sequence commonly known as cyclic redundancy check is added to the end of the bits in CRC. This is done so that the resulting data unit will be divisible by the secondary binary number that is predetermined. The receiving data units on the receiver side needed to be divided by the same number. These data units are accepted and found to be correct only on the condition that the remainder of this division is 0 and the remainder shows the data is not correct, so that they need to be discarded. Here we can see the example for the cyclic redundancy checking method. The original message has been sent as 1010000. Here with the generator polynomial we considered as x cube plus 1. Thus the CRC generator formed as 1001, that is 4 bit. In the sender side we are considering the original message with the extra 3 bits because of CRC generator. 4 minus 1 it is 3. Thus we consider it, and it has been divided from the CRC generator, and it is been done the XOR operation with the original message, and thus the final result has been considered, and the result has been added with the original message and thus divided with the same CRC generator and done the XOR operation with it at the receiver end, and this thus the final result has been the 0. Therefore 0 means the data has been accepted. The disadvantages is the cyclic redundancy check may lead to the overflow of the data. Thank you everyone.